Today we're going to be talking about joint consumption, and you might be wondering why I have a Super Bowl crowd behind me. We're going to be using the Super Bowl as one of the examples in our discussion today, and we'll have some fun with that. Now, the idea behind joint consumption is we generally don't consume goods in a vacuum. Sometimes we might be sharing a plate of cookies, or we might be buying a sandwich at a shop, or we might be watching a show on the television. And when we are consuming, how does that affect other people's ability to consume that good or a similar good? So let me bring up my slides and we'll talk about it. So the joint consumption model is one that was developed over a period of time by a number of very important economists. And the idea is that you are looking at consumption from the standpoint of whether or not it's rivalrous or non-rivalrous. So, for example, a plate of cookies would be a rivalrous good, and that means if I eat one, there's less for you, and vice versa. Whereas a non-rivalrous good would be something like sunshine. If I'm enjoying the sunshine and we're not standing on top of each other, you can enjoy the sunshine as well, or I can listen to the AM radio, you can listen to the AM radio. We don't have any impact on each other's ability to listen to that music. There's also, on the other axis, the question of excludability. What if somebody can exclude you from consuming a good? And that would mean, for example, if I own the cookies, I decide who gets to eat them. And if I own the venue for a concert, I get to decide who's going to listen. But you can also have non-excludability. And this could mean nobody is in control of who gets to consume the good. This was the case with the American bison. The American bison roamed free on the plains, and nobody owned the bison, at least in theory. And the result was that when they built the trains traveling across America, the passengers riding in these very slow-moving trains got bored, didn't have the internet, and so they got their rifles out and they just shot the buffaloes as they rode by, butchering them and eventually killing hundreds and hundreds of millions of them. That would be a common good. It was rival. If you shoot one buffalo, there's one less, but it was not excludable. And then, of course, you can have a public good. A public good would be one that's also non-excludable, like the US military. If you're an American citizen living in this country, you get the benefit of the military protecting our borders and protecting you from foreign invaders, whether you pay for it or not. So there are these four goods: the private good, which is rivalrous and excludable; the club good, which would be non-rivalrous but excludable. And this is an example of this would be XM Sirius. It's not rivalrous. My listening to it has no impact on you, but it's excludable because it's encrypted. So you have to pay for it. And I've given you examples of the common and public goods. Now, I was looking at this one day because it's in every textbook practically. And I was evaluating it from the standpoint of the first order of derivatives using calculus. And one of the things that we do when we look at the first order derivative is we want to know, how does a change in y impact x? I mean, that's really what we're trying to estimate. And so if we look at the rivalrous good, the first order condition of a rivalrous good is less than 0. That means that if y consumes one good, there's less good for x. Okay? The consumption of one unit by y reduces the number of units available for x. Now, in the case of a non-rivalrous good, of course, it would be the first order condition equals 0. If you consume 1 unit of good, there's no impact on me. So x is unchanged. So the question is, what's missing? I was looking at this one day, thinking about it from a mathematical standpoint, and I asked myself that question: what's missing here? And then I realized it was this. What about the first order condition where if y consumes a unit of good, the function of x actually increases? X goes up. And so I filled this in and I've created another set of boxes. Now we have to have a name for it. And I found this archaic word conducible, which means to contribute to. And I said, what about conducible goods, where the first order condition is greater than 0? And I gave them names. An excludable conducible good would be a mutual good, and a non-excludable Mutual good would be a crowd good. Let me give you an example. Let's take Instagram. What good is Instagram if you have no friends? Not really very useful. In fact, as you increase the number of good friends, the conducible benefits of Instagram go up. And that would be true of, for example, holding a Super Bowl party at your house. Watching the Super Bowl party alone, eating a few chips and drinking a beer, not too much fun. But if you have 5 or 6 of your best friends there, you're shouting and screaming, and you're consuming the Super Bowl together, well, everybody has more fun. And so therefore you have a conducible good. This would be true about going to a concert and enjoying being part of the crowd and so forth, or going to the Super Bowl and being around everybody cheering and having a great time. So what's a crowd good? Well, a crowd good is an example of that same kind of a thing, but where you can't control who's there and who's consuming it with you. This would be a problem, for example, at the Super Bowl, if there were no security guards and people started rioting and beating each other up. We see, of course, crowd goods all the time with politics, where you have a group of people who are expressing their political opinions together, conducible goods, by marching and making statements and yelling out, in a reasonable manner. And then somehow it turns into rioters and they start destroying property. Well, then it becomes a crowd good. And so having excludability, being able to control who's there, who's not there, makes a big difference. If you have a Super Bowl party and one of your friends gets drunk and starts causing all kinds of problems, you can toss him out the front door and you can go on to enjoying the game. So what we're going to do now is we're going to talk about each of these goods from the standpoint of a game. So to do that, we'll begin with the private good. And in this case, we're going to have a quantity of 6 units of a particular product, which is cookies. We have a plate of delicious cookies. It turns out that player number 1 has a utility function that says the utility minus the price for the first cookie is worth 5, the second cookie 3, the third cookie 1, the fourth cookie 1, the fifth a half, and the last one a quarter. In other words, diminishing marginal utility. As you eat more cookies, each cookie becomes less and less enjoyable. Utility function for player 2 is slightly different: 4, 2, 2, 1/2, 1/2, and 1/4. Now, because this is a private good, the first cookie that comes up for sale has to be purchased. And since player 1 wants it more than player 2, he will pay a slightly higher price, and he will get 5 units of utility. But the second cookie that becomes for sale, player number 2 is willing to pay a higher price, so player 2 will get that cookie and will gain 4 utils. Then back to player 1, who will pay 3, player 2, 2. Player 1 will not get the 5th one because player 2 has more utility. Player 2 will get the 5th one, and then player 1 will get the 6th one. Now, if you add those utils up, 9 and 8, you reach a total utility, joint utility, of 17. So that's our joint utility benefit of a private good. Now let's look at the common good. In this case, we have exactly the same utility functions, the ones we had before. But in this case, whichever player gets to that plate of cookies first is unexcludable. You can't exclude them. So what are they going to do? They're going to take all the cookies. So player 1 goes up, takes all 6 cookies, and the utility is equal to 10 3/4. On the other hand, if player 2 gets there first, take all the cookies, it's 9 1/4. So the total utility is either 10 3/4 or 9 1/4. Same utility functions, same cookies, but our utility drops. The common good is not efficient. How do we solve this problem? Well, very simple. We provide somebody, a third party, ownership of those cookies. And that third party then can sell those cookies to the appropriate person to gain the highest utility. Let's look at the club good. Now with the club good, you have a situation in which somebody is deciding who has the right to enjoy the cookies. And because there are 6 cookies, they can say, we don't want it to be rival. We're going to make it non-rival, by having 6 members of our club, and every member gets 1/6 of the cookies. So in this case, player 1 gets 3, and player 2 gets 3, and we get total utility of 17. Now let's take those same plate of cookies and deal with it as a public good. In this case, we have a problem. Nobody has to pay for any cookies. They can just take them. And cookies have to be made. So if you're a supplier and you're not going to get paid for your cookies, what are you going to do? Well, you're not going to make any cookies. So the utility from a public good would be 0 because there will be no cookies. How do you solve that problem? Well, there are 2 ways. One, you could tax everybody if you're the government, forcing them to pay for the cookies and then have somebody produce them. Or you could have each person enter into a contract, which you could take them to court over, saying how much they're willing to pay for each cookie ahead of time, and then you would bake the cookies and collect the money. So there are solutions to these.